All right, I think we're live. Welcome. This is Brook with Printrbot.com, Printrbot Live on Facebook, and later on other places, YouTube and such. Well, Happy New Year, everyone. It's 2018. It's 18, right? Yeah. 2018, and I'm excited about the new year. So, I've got some new projects that I've been working on. You know me, we need more projects, right? Well, I want to first kind of do a recap on Adopt-A-Bot, because I don't want to forget about Adopt-A-Bot. So we did not sell and ship the 100 that I was hoping for by the end of the year, but we're just going to let it roll for a while. It's $75 on sale, and I just packaged some up today. And we've got some that are waiting even for next day shipping. I don't know if you want to put that, Dave, but it's a quick shipping. And the Adopt-A-Bot, if you don't know about it, it's an encouragement for people with printers, 3D printers that are laying around. It is my call out for you to get those things running that you don't need and that you could donate to a local school. So first, get yours running and donate that. But if you don't have an extra one, for 75 bucks, you get 4 motors, you get some wiring, a printer board, a hot end, everything that you need except the files are online, and you will print and build and hand deliver and even support a local school with a 3D printer. So it's called the Adopt-A-Bot. You can go to adoptabot.org and find out a little more about it. I need to update the website because I'm gearing up to expand it a little bit, but I don't want it to be forgotten. We're going to stop selling all of the kits once we reach 100 kits from Printrbot. And we looked, Dave, do you remember how many that I've shipped? Wasn't it around 70?
Yeah, I mean, if we're counting those first couple rounds, it was 60 or 70.
So I've shipped around 70 from here. 30-some of those I just shipped for free. Whether or not they made it to schools, I don't know. We also have, if you just want to do something easier, I encourage you, I think we're putting one more play in the store. Is that in the store yet? That is in the store. There is one more play. And this is a bare bones kit. So we did have some injection molded parts that we kept in stock, but we have posted those files a long time ago. And you can print those injection molded parts, and you can build up with some extra electronics and stuff. If you have things laying around, motors and things like that, you could buy that one play, build it up, donate that. Or there's a few more, I want to say a dozen or more, Printrbot's simples that we have. In fact, these might be some of them. I'm basically getting rid of my extra stock. We had Print Farm, and we've had various ones that were around here, and we're making sure those are refurbed and ready to print, that they print well. It's usually just changing out the belts, making sure the hot end works, making sure it prints well, and then we're selling those for really cheap. I think those are 300 bucks. But anyway, we're trying to get printers into the hands of people that don't have a lot of money, and schools fall into that category. So I'm not giving up on Adopt-A-Bot, but I will once I sell out the kits that I've prepared here. Basically, it's been a labor of love. Me and my wife have done almost all of the work for the Adopt-A-Bot program. We are getting to the end of our spare motors that I can't sell, and our UBIS hot ends that we've refurbed. Sometimes we get returns and we have parts and we can make those work. We put new tips on them. So I'm coming to the end of my readily available, easy to give away equipment that go into the Adopt-A-Bot. I do have lots of printer boards, and so we're going, I think we've been shipping F5 with those, yeah. F5 is, the difference between F5 and F6 printer board is just simply there's no extra fan in the F5. F6, we added an extra fan. There's a couple of pins and things that are different, but, header pins. But it works for a 3D printer with one fan, and the Adopt-A-Bot is that. So I have lots of boards, lots of F5s left, so I can continue to sell cheap boards, but I need your help. So this is a call out to people that can Google and already have sourced some of the following items. So the Adopt-A-Bot, to go from a cheap kit from Printrbot to self-sourcing is what really needs to be the next phase of the Adopt-A-Bot. I need to leave the files up there, but we might want to put some derivatives up on adoptabot.org. I've already noticed there's one guy that did a great job modding his Adopt-A-Bot to fit a regular ramps board, and he even put a switch on the back and some extra things on his. I think he used E3D's hot end. So I really encourage, if there's people that have files for the Adopt-A-Bot that they've modded, I will post those on Adopt-A-Bot, so share those with us. But here's my dream. The biggest costs are currently, the printer boards do cost more than a Chinese ramps board, so we could do an Adopt-A-Bot with a Chinese ramps board, but I'll be able to sell those F5s and even might go back to F4 and even reach back further in my spare boards that I have here. But I'd love to put some links up. So if you are into the Adopt-A-Bot program and would like to start helping me source a Chinese hot end, E3D knockoffs are all over the place. Some of them are bad, some of them are good. And I have not yet just bought a bunch of those to see which one is best. I do have some Chinese ramps boards that I've got. I just need to go through and make sure they work well and to see what the difference is between them. But they are cheaper. But anyway, so I want to put some links up on adoptabot.org of possible equipment, and we might even pair those up with derivative models. For instance, if you're doing a E3D Chinese knockoff hot end for your Adopt-A-Bot, you're going to need a different file to hold the hot end. So we could put derivatives that match basically a BOM, or at least a list of links of where to source the hardware for these files. Now, I do have lots of bars. I can continue to sell bars and bearings and things like that. So once I sell out of these Adopt-A-Bots, we'll need some help with links and people testing things that are available easily, like Amazon.com or eBay or something like that. So how do you share those? Very good question. There is an Adopt-A-Bot email. I'll have Dave find that, because I know it's something like, I forget what it is. It's at adoptabot.org, but it's something like get involved, or what is it? Engage. I think it's engage. Anyway, we'll try to get an email posted there. So if you have links to good equipment you think belong in the Adopt-A-Bot, for this reason, it is fairly good quality. It doesn't have to be the best. It just needs to work and be from a manufacturer that has a good track rating. And it needs to be cheap. So there's already one of the things, when I run out of motors, I feel kind of bad because I know $75 is a great price for the package that I'm sending out, but it just can't go forward, because I'm losing money on all those. But there are some great deals for like motors, packs of 4 motors for a 3D printer on Amazon. So anyway, the Adopt-A-Bot, I want to go forward, but enable people to just self-source their equipment. You don't have to buy mine. It's not about promoting Printrbot, although I do have cheap boards I'll continue to sell, and that will probably beat the price of a ramps. But eventually those will run out, and we want this to be kind of a DIY thing that you can just do yourself without needing to wait on me and my wife to put together packs to send out. We'll just get some good links for great places to source hardware, and links to the software and the files, and it'll just take on a life of its own. So the Adopt-A-Bot is named Bot because I don't want to limit it to just printers. So that's what I have here today. So I see schools not just needing 3D printers, but I really believe in teaching them to use robots, teaching them to program Arduino, programming in general. One of the big areas of interest that I'll be into this year is CNC. And so I've drawn up this CNC. And originally, I just took, this is just a little CNC that I've been drawing for the last few days. And this is fairly traditional. If you remember, Printrbot did make something called the Printrbot CNC. I don't have one in here. I've got a few of those to sell. I still have a few products that I will be putting on sale for unbelievable prices, and I'll just watch my Twitter feed and I'll talk about those, and I'll talk about it in the show. But the Printrbot CNC, I probably have 5 to 8, some parts laying around I need to complete, make sure they're working kits. But that was, I think it started at like $3,000. We overbuilt it. It was so rigid and used so much metal and was so heavy that while it was a great machine, it just was out of the price range of a lot of people. And so I kind of went back to the drawing board and thought, well, so why did I do that? Well, I did that because I wanted to, me and Brian designed it, and I wanted to have a CNC machine that was better than, say, an Inventables CNC or a Shapeoko or whatever, because those, they call them carvers or engravers, because you know, engraving or making a PCB was what a lot of people were doing, and then they got into routing, CNC routers that just do wood. Well, I wanted to do metal, and so we built a machine that did metal. But, you know, we overshot. And so that, while that product is dead, I will bring it back just to sell the ones that I have on hand for very cheap. And when I say cheap, we're talking about this, they'll probably be around $1,000, $9.99 probably. So there'll be a few of those available soon if you don't want to mess with building your own. But those, we ran the Tiny G V9 board. Not to get too deep into the weeds, but Tiny G goes back many years, and they made a CNC controller, and then we used that company to build the electronics running off the same firmware. They switched it to G2 Core is what the Tiny G firmware is called now. And the code actually runs CNC and 3D printers. So it's always been a dream of mine to convert my CNCs, not just the Printrbot CNC, but we also have one called the Crawlbot. And the Crawlbot is for 4 by 8 foot sheet of plywood, and it's a CNC router. It uses a DeWalt router. Doesn't really matter what router it is, but so I'm going to be updating the Crawlbot. That's a real product. It does sell, albeit fairly slowly. It's consistent enough, and so after a couple years of using the Crawlbot, I've been wanting to update the electronics in that to use more powerful motors. One of the things about the Crawlbot is you have to go slow. It's not like a ShopBot 4 by 8. That's like 20 to 30 grand. This thing is it 3,000 or 4,000? Anyway, it's a lot cheaper, but you have to go slower. And it does use belts. And so not just belts, it uses a lead screw on the Z, but it uses belt for X and 2 belts strapped down to the table for Y. So I'm going to be updating that, and I'm testing rack and pinion right now. And so when we update that, we'll have rack and pinion, so it will be much more powerful. No stretch with belts. You get a little bit of stretch. And it'll be more accurate and much more rigid. Although you will have to buy the pinion rails. I think it's really worth it. Lots of plans for the upgrade on the Crawlbot, but I figured why not start small and first just hook up because I want to try this G2 Core. They're coming out with a new board that I'll use that gives a step and direction, and you can use really big motors with like Chinese drivers. And that's a big deal because you can use not just NEMA, 17s? NEMA 17s, these little motors, but NEMA 23s are on the Crawlbot, but they're limited in amperage, and so that means power. And then you can actually bump up to NEMA 34s for a big 4 by 8. So it'll be a much more capable machine. We'll see where the price goes. Hopefully it'll go down, but we'll just have to see. But anyway, so CNC will be a focus this year, mainly because Printrbot has, I just have to do the tools that I want to use, and I feel like the company, if it reflects the passion and vision of the founder,
or the CEO, that, be a company that's doing things that I like, and that's the fun stuff. So anyway, but education also, I believe, can benefit from CNC. A story I tell, I went through the shop program in Altamont, Kansas, Labette County High School. And it was a community high school. Lots of kids from small towns would go, and there was a shop program. And so before I got into the actual shop program where I learned welding and auto body, auto mechanics, machine shop, they had a good wood shop too, but I chose to go with the metal route. And I got into that in my senior year, and I wished I would have done it all 4 years. It was a great tech school. Kids there at LCHS, they graduate with enough skills to go right into a job, skilled job where they don't have to go to college if they don't want to. In fact, I went through the electronics program. I only did it for 1 year, but I was friends with the teacher, and I'm friends with Marty Warren to this day. And there's kids that are learning electronics at my home high school. They get out, and they make a higher wage than kids that have gone through a formal college to become electrical engineers because the program is so good. Just really leads in that whole state of Kansas. So I was also into drafting too, by the way. So I got to do art and drafting and learned a lot of skills in high school. So that's coming back to America for a long time. There was a book that came out called Shop Class. What was it called? Shop Class is Soulcraft or something like that. Saying that it's so sad that a lot of high schools just let go of all of their great equipment, and we thought we were just going to be, the information age. We're just going to learn how to program, and that's enough. Well, it's not. You need to know how to fix stuff. You need to know how to create, how to build things. And so that kind of was the background for why I really declared myself a maker and founded this company, because I believe Americans and kids in schools should learn how to make their old cars last a long time. Right, Dave? 195,000 on your Tahoe? That's awesome. I've got a 65 Gia I just can't let go of. Lord knows how much mileage. It actually sits more than it drives these days, but I believe in making the things that you have work, fixing them. And 3D printers are great in doing that, but also some knowledge that you learn from shop class or in high school or just tinkering around in your garage. So the Adopt-A-Bot program, to make a long story longer, the Adopt-A-Bot program is endorsing schools to get into 3D printing, but it's a short jump to CNC. So here's the model that I've created, and what I did is I just went to my shelf and I looked. It's inventory time of the year, and I have some, equipment that I overbought slightly, in some cases dramatically, but we've retired the old Plus, and we've retired the old Simple, and we've retired the Play, and so I have extra parts. These parts go all the way, these blocks go all the way back to the original wood Plus and LC. So I didn't really incorporate these into the design. I'll show you the design here, and I'll share this shortly once I get this built for the first time. Let me see. I'm going to show a screen here, Dave, so you'll have to help me. But the idea is a very small CNC that could do, tell me about the angle of this. That's good? So the idea is a small CNC that you can make very, very easily. So if you just had some MDF like I have here, and, like a chop saw, or not a chop saw, like a hand saw. Not a hand saw. It has to be powered, but just a power saw. And you could cut a square, and these are kind of fancy shapes here, on the sides for these arms. But these could be cut with just like a skill saw, something that you could buy off of Lowe's. What I did was, just to mock this up, I just laser cut these. But I'm going to use parts that I have available for this early mock-up here, but then I'm going to design parts that are easily 3D printed. So these blocks will be replaced. I'm printing them now. These, I call them bar ends, but they'll also have, this is going to be a bot that is completely Acme rod driven. So I'm dumping the idea of belts because the experience with the Crawlbot, although it's okay when you get good belts with steel reinforcement and stuff, it's just CNC should be Acme rods or ball screws or something like that. So, but this little one won't need much push. So you can see on the X here, it's already hooked up. These are actually parts from the Simple. And so I can even just turn it around and show you. That's the Simple right here. This is how it would sit inside of a Simple for the Z and the Y. But we put these little small bars, the same ones I use in the Adopt-A-Bot. And right now it's belt driven. But I don't have a lot of these, and I don't think it's really wise for me to incorporate something that I don't have a lot of. I want it to be a design that's easy to make and utilizes standard off-the-shelf parts. So you can see here, I have a lot of these. These are LMF, LUU, or LM12F. I forget it, but anyway, I got a lot of these. So I'm going to use these, and they were used in the Plus. So I've got those. I'll put together a kit with these Plus bars, the files to print the bar ends, the files if you want to cut your own, I don't even know what to call that. It's kind of the support for the X. It's not really Y. But anyway, so I'll change these parts so it's not belt driven, and it'll be lead screw driven. So you can 3D print a small CNC, and you can donate that to a school. So, of course, you can build it yourself and just enjoy if you want to. But since I have parts to share, it kind of inspires me to utilize the things that I have and get to designing to not just sell those. It's not really about making money. It's about really breaking even on these bars. But also, they're just bars, and these are common parts. A lot of CNCs use these things. I decided to go against, on the small one, linear rails. The cost between designing a bot, a printer, a machine, a CNC, the cost difference in round bar versus linear rails is dramatic. Now, I used to source linear rails in China, and I still get some from China, but I'm really switching over to all Highwind because the tolerances are just better. And it's a U.S., I'm sure they make them in China, but they distribute them in the U.S., and the tolerances are great. But you can bet on what I figured was about 4 to 5 times more just for the bars and the rails, or the rails and the bearings. So a fourth or a fifth of the cost to go with round bars, it's good enough for these small ones. So anyway, this will be a 3D printed. There's 3D printed parts here. They're stacked over here. There's only 3 right now. This will grow as I finish this machine. But there'll be some printed parts up here. But that's enough for like engraving. You can engrave plastic, wood, even metal. In other words, not cut very deep into it, but you can do wood, cut all the way through it. So if you don't have a laser cutter, which I've thought over the years I was going to design a laser cutter, but there's some pretty good laser cutters out there that are really cheap. Now, again, they'll be made in China, but they are cheap. So theoretically, you could put a little diode laser on here and have an engraver. I also designed this so eventually, if it goes well, there's a lot of options here. You could put a little laser on here if you wanted to. That can be dangerous, so more on that later. But you could make this a 3D printer if you wanted to. I can put more travel in this Z. But the reason I limited the travel is I got on Amazon and I got this. This was, at first I searched for Dremel, but these little Dremel tools, there's a lot of these that you can just buy at Lowe's or whatever. But check this out. So this will mount right here, and it won't have a lot. It looks like it's about 2, 3, maybe 3 inches of travel right now. That's probably enough if you're just going to strap a Dremel to it. I'll 3D print a mount for this, but this is a $20 Dremel knockoff. And it spins very fast. You control the speed here. Just on Amazon, it's like literally $20. And you can control by hand how fast it's spinning, and you'll be able to, you can make PCBs, you could make, you know, any kind of crafts. You can even cut through like 1/4-inch wood or plastic, and you can learn about CNC with very little money spent. Now, if that's not enough for you, because, you know, the bearings in this, you know, probably have a very, very real shelf life. You could do a Dremel, you could do something else. So I also got one of these. Now, this came as a kit. This was like $135. This is the speed control for this. It's a brushless, or wait, this might be brushed. It must be brushed. It's two leads. So it's a brushed DC motor. It's going to be pretty loud, like it'll wind up real, you know, like a router would. But you can control the speed here. So I just wanted to know what was available on Amazon that was really easy. I got this one because it had this beautiful mount. It comes with the mounting screws. And so you can imagine the holes to mount this. Now, why a Chinese spindle? Well, eventually I'm going to figure out what we can use to control the speed of the spindle. The difference between mounting, by the way, you could mount a router to this. The DeWalt, I forget what the model number is, but it's 611. On Amazon, they're like $125. Very, very, very good routers. In fact, you'll see Inventables and even ShopBot. I think I saw, was the HandyBot? I think it uses one of these. But on like CNC, what is it, Open Builds. There's a bunch of you know, DIY CNC websites I've been trolling, but the most popular router in the U.S. is the DeWalt 611. It has a really cool feature where it can start out slow and adjust its speed based on when it's cutting through something. It'll adjust its speed a little bit. So it has a speed controller, and it keeps track of its RPM automatically. There's even an open source speed controller that I'm looking into that taps into that DeWalt, or you can retrofit it to any router and control the speed programmatically through the host that will run the CNC, which I'm going to talk about in a second. So anyway, but these, a lot of people use these because they're cheap, you know, $135, and you can control them electronically, not just with a knob, but Gerbil or Gerbil is a common firmware for, well, it's Arduino based, so it'd be like if you have a ramps board, you could load Gerbil onto that and control the whole CNC. Now, I've got some links that I'll need to post on a post to give you all these, but there's a guy called Link-O-Matic that took an old, way back in like 2011 or 2013. Link-O-Matic was this guy that took an old printer board, this is a new one, and he ported Gerbil, which is a CNC firmware, to the printer board. So it's possible to use my old boards and put CNC control software on here, and you can run it from a host program that I've recently found out about called CNCJS. If you want to check that out, it's cnc.js.org. And CNCJS, it's what I've been waiting for such a long time. There was a lag, and lots of people are interested in CNC, but they went with Mach 3. Mach 3 is like, if you remember your old printer port on your 486, you know, that printer port you plug a printer into. Well, CNCs for years, and even still, they use Mach 3. It loads onto Windows, and you control it from that parallel port, from an old printer parallel port. Old, ancient, and it bugged me. I didn't want to use Mach 3. And so what I'm doing is, I'm using TinyG, and I brought the TinyG board out here because the Core G2 that runs our printer with this legacy shield, you can just run a CNC straight off of this host software with the same firmware. You don't even have to change the firmware. So the G2 Core firmware that runs our printers will run CNC no problem. It recognizes, the difference is in 3D printing and in CNC, they use G code. So, this thing moves around based on G code. But there's different commands in G-code for CNC. In fact, that's the oldest G-code is for CNC. We added, a hot end that has to have extrusion and temperatures and a heat bed temperature and all that, and it complicated it. And so Gerbil was an early way to take the same hardware that runs 3D printers and run CNC. But G2 Core is great because it does both. So you can just load the host software to run it, and it can just talk to this. You can take it out of your printer board or your Printrbot Simple Pro and use it to run a CNC. And by the way, the firmware on this is way more advanced than what will run on these older printer boards, Gerbil. Gerbil and G2 Core are worlds apart. G2 Core can run way faster, and it's way more elegant. It's just really, really good. But I want to get it working with both, so that'll be fun. And then I want to try it with these different spindles, both like a super cheap $20 job and mill a PCB or some little project. Try it with just a straight up electronic controlled RPMs for a spindle like this, which, the bearings in this are a little better than this because they're bigger, but also this is really meant to do CNC routing. But also want to try an option for a router like the DeWalt. And then I even been trolling, another kind of recent thing in the last few years is quadcopters and RC cars. Those motors for RC cars and quadcopters have gotten so good and cheap. And so I started to order, but it was on eBay, and I couldn't remember my password. So I'm going to order a little collet. A collet is what holds the cutting bit to cut your material. I'm going to order a collet that can bolt right onto a RC brushless DC motor. Brushless is interesting because it's controlled through PWM, pulse width modulation, but it electronically controls the speed. So you get up into like a very, very nice feature of CNC is being able to, in the software, say, well, I'm cutting wood. I need the router to spin this fast, exactly this fast. The hackerspace down in Rockland, when I went to visit and saw the Crawlbot use cnc.js, let me go to that site real quick, for the first time, he had a little chart where he had a tachometer, like this laser, and he painted a white strip on the spindle, and he would see, well, on the Bosch router that we use, if you turn it to 1, it's about 12,000 RPM or whatever it was. And then if you turn it to 2, so he had to make this Excel spreadsheet table so when he's cutting wood or aluminum, he knows which dial to put it on. So that's one added frustration of CNC routing. So if you have an electronically controlled, like a brushless DC motor, they could get very powerful from the RC world. You can put it into your program, what material you're using, and it knows how fast to spin. It starts up, it stops on its own instead of you having to hit a power switch. So that's really where I'm going, something that's really nice to use, but uses cheap options on the spindle. And RC equipment is one option. So I'm going to try all of those different options with something like this. And then I think in the open source world, part of the problem with somebody that says, I want to build my own router. Well, there's hundreds of plans of routers out there. And this one is just going to be cheap. So the goal is cheap. And then secondly, the goal is to, instead of listening to 100 different sources and herding cats, I'm just going to decide on, well, this is the choices we made. Here's why. Here's the firmware. If you want to use Gerbil, here's how to set it up. If you want to use a router, here's how to use it. But all the way up to, here's a really nice solution with G2 Core. And we'll put an e-stop on it. We'll make it safe. And we'll use an electronically controlled spindle, something like this, or something out of a really powerful RC car equipment. So anyway, that's the deal. Let me pull this up, cnc.js.org. When I was developing the Printrbot CNC and the Crawlbot, I'll get to questions here in just a second. I see that Dave's got a couple ready for me. I will answer those. And then if you have new questions, I'll take a few minutes at the end here to ask a question. So if you have a question, get it in now. I'm almost done. Here it is. And I want to show you, originally we were trying to run the, can you see that okay? Okay. We were trying to run our Crawlbot and our Printrbot CNC off of Chili Pepper. Chili Pepper was Raspberry Pi based. And I thought, awesome. Well, those guys are fantastic. I mean, we had Google Hangouts with them, and we were trying to figure out all the software problems. But it just, in the end, it was pretty buggy. So we got tired of, and by the way, the problem is, you know, we're Mac people, and Windows has options, but they're kind of stagnant. So you might see Mach 3, which the interface is, you know, 1980s. Mach 3, although people all over the world use Mach 3, it's just not modern. Because who buys a laptop with a parallel port? We use laptops now, so you need a USB port. Well, they had options for that, but there was no real elegant, works on Mac, works on Linux, host software. So these guys developed Raspberry Pi, a solution that was like this headless Raspberry Pi would sit here, and you'd, you know, log into it remotely through a browser, and you could control it. But it was a lot to do for a couple of guys. Well, we've come a long way since then, and we ended up, by the way, writing this little simple app to run our Crawlbot and CNC off of a Mac, where you just plug in the USB and it works. But it was really just about loading the file, homing it, and then starting, you know, it lacked a lot of nice features. Well, now, CNC.js, you can see this interface is very nice. It's open source. It runs on a Pi. You can run it on another computer. But I'm gonna put a Raspberry Pi on here to run it, and then you can use a browser. So any, not a USB cable, it's just any browser. Technically even your phone, but really you'd want like a touchpad or something. So that missing piece, that host that is a web server that you don't have to add a screen to this, really, really is nice. So the timing for all of this is very, very good. So anyway, CNC.js, I'm excited about using it. And it actually has some, it'll actually path some very simple things. But you know me, I love Fusion 360. And Fusion 360 has a post processor. Once you do your design, you can say, I want to route it out of wood. And it'll prepare the G code, the right flavor for Gerbil or your G2 core, Tiny G. So the tool chain is starting to kind of show up and not be a lot of money and work from whether you're running it off a USB cable on any platform or you just got it on a Raspberry Pi and you're using a browser. So anyway, I'm excited about CNC, and I'm like you, if a lot of you haven't done this before, don't get any ideas. I'm not some master machinist at all. I like Fusion 360. I've done some very simple CNC pathing. But really, the best I've done is when one of my employees, like Brian or Steve or now Mark, they show me like how they prepare the file. So I'll be learning this along with you, but I know that it has application in the classroom, application for makers, people that are into DIY, and the missing link, I think, is cheap hardware. And there's a lot of aluminum extrusion stuff out there. The Crawlbot uses that. But everybody makes design decisions when they try to get the cost at a certain price. And if you run with belts, it's just not going to be great. I think you need Acme rods or ball screw on anything that you do, or if it's not going to be very accurate. They also make weird decisions like, you know, the Crawlbot does use Delrin wheels on aluminum extrusion. I'm not going to throw that out. I did a really weird thing. I used inline skate wheels to roll over that 4x8 plywood. So we're not ditching all the weird ideas, but I think there's a better decision than belts, and that's definitely rack, and I'm looking into also some other solutions. But anyway, the point is it was hardware cost, and then the software tool chain was what really you know, kept people out of it. Some of this old school stuff, like there's some really good programs like Vectrix and others, that are just, they're so 1980s or 90s. Fusion 360 is so much better for pathing CNC, and that is a powerful piece of software that will speak to these cheap and expensive machines. But anyway, so that's where we're going this year. That's one thing. Now, I talked about Adopt-A-Bot. I talked about the Adopt-A-Bot CNC. That's what I'm going to call it, by the way, Adopt-A-Bot CNC. And again, just going to keep it cheap. But I'll do that crawl bot, and I'll have this learning that I'm going through will translate into products, of course. But I don't want to forget the printer belt. So I almost brought it in here today, but I got a little behind with some other work I was doing. The 2018 #1 goal is get printer belt out there and for sale. Again, we have two models. The 6x6 by Infinity. It's a little tongue-in-cheek. You're not going to print something infinitely long. But it does really, really long Z, like this. So it's crazy. So that is a special machine that I've been kind of holding off on to clear my plate and to have a little better timing, and now is the time. We also have a 12x12 by Infinity version that we're working on. In fact, the 6x6 is done, but I wanted to get the 12x12 done so I can launch them simultaneous. Now, this next thing I'm going to tell you isn't going to slow the launch of those products because I have an engineer that's working on those now. He shipped his last thing that was in the way today, and now he's 24/7 on printer belt until that launches. But the one thing that I realized was, I stopped building rep wraps. I went back to it with Adopt-A-Bot because it has a good price point for Adopt-A-Bot, almost $0. But with the printer belt, I had to build that out of metal, and so the price of the 6x6 is going to be, I think it's $1,500. The price of the 12x12 might get up to $3,000. So that's a lot of money. That's too much money for most people, right? So I just made a decision when I'm contemplating what I'm going to do this year. I made a decision to go ahead and design a very small version of the printer belt that will be completely, it's all open source, but it'll be totally affordable for people like you to build one yourself. And I'm going to use, again, I'm going to go to my spare parts bin, and I'm going to use readily available parts. And I want to put the plans out there that you can retrofit a bed. I had one that I showed, but it was about that long. And even making that out of metal was just, it was a lot of money. It was just like buying another printer. So I'm going to make a very tiny printer belt that you would be able to strap on to a simple. I don't know if it'll fit on the Adopt-A-Bot. I guess I can look at that. But this will be small, probably more like a 4x4. Maybe it's 4x6. X and Y, and then Infinite Z. So I'm going to be working on that here in January, and I'll release those files so that people like you that don't want to spend $1,500 or $3,000 can at least download those plans, get the stuff yourself. I probably won't even, I don't know if I'll sell a kit for that because it's not the point. I just want to get the design out there and get people using it. Get feedback would be nice. But I think this is something that's really, really different and useful for 3D printing. All 3D printing companies should do a printer belt. You'll have to call it something else, but it's just the size constraints of 3D printing. Sorry, folks, we're back. Yeah, I killed the battery again. Sorry about that. So real quick, just want to finish up. Where was I, Dave? When did it cut off? Printer belt. So if you just tuned in, we've basically had 9/10 of the show, and then we lost the battery. But I was talking about the printer belt. I want to make sure it's clear that I will be posting files for RepRap, printer belt, add-on to whatever printer you have. And I want to get that out in the wild, so I'm going to do that. And the hope is I'll get that released by the end of January. I'd love for that to release at the same time that we have all of the other ones for sale, the two 6x6 and 12x12. All right, so that's printer belt. Also a question on what's the update for the flex plates. We got the flex plates in from our metal laser cutter.
manufacturer, Microform Precision in Sacramento, and they are at the, what do you call it, the plating. They're getting plated. So I'll have a few of the, it's really a test, it's a test balloon to see if people want these flex plates for their legacy bots. So if those sell quickly, I'll turn around and I'll get a bunch more made, but those should be coming in any time with the nickel plating. I could have sold them without the nickel plating, but I didn't want to skimp on quality, so they'll be very, very nice. Now you can use those flex plates, by the way, just with some clips, you know, like these, what are they called? They're like those triangular clips that you clip paper onto a clipboard or something like that. Anyway, you can put that right on, and it is made of spring steel. We recommend you do look into, well, of course on the Simple Pro, it's magnetized. So spring steel does hold the magnets, and the magnets come in the upgrade kit or the, yeah, let me see one of those, or the stock. If you buy from us, you can get a Simple Pro with the heat bed and the magnets and the whole 9 yards. But this will work if you've got another printer and you just want to take the spring plate, clip it on, do your print. You can even put blue tape on there, and then pop it off by bending it, put it back on. You will have to adjust your sensor. So anyway, I know that I've mentioned that many times, and it's just been very slow. So we're coming to the finish line, or at least the starting line for that product. Here's another question. Is Brook going to try to use a quadcopter motor to power a spindle? I actually have, well, not anymore. I took it apart. But I took an old one, a simple metal, and I put a straight plate on it, and I built my own really janky spindle using a quadcopter motor. I have a bunch of quadcopter motors, all different sizes. And yeah, that's, I think, a good idea. There's some great videos on YouTube where you can use those with a ESC tester. So it has this little dial. There's like 12 bucks. And you can just hook that right in and zip, turn it up. It doesn't tell you RPM, at least the one I have doesn't. So really the goal would be to find the electronics. I know that there's some Arduino projects out there that allow an Arduino to be a middleman in between Gerbil or Mach 3 or whatever you're using for your host software, and give it the right signal so that you can electronically control it in the program, so it can turn on and off and do different speeds based on what it's doing, drilling or plunge drilling or routing. So yeah, I think that's a good. What was that number there? Can you scroll down just a little bit? What did that say?
0.042, I think.
But what does that mean?
How thick are the spring steel plates?
Oh, I don't know. I don't know where my calipers are. I'm not sure what the thickness is on that. I sourced it just off of McMaster Carr, and we tried the different. The question is, how thick are the spring steel plates? Off the top of my head, I don't remember. We sourced them off of McMaster Carr in like 8-foot lengths, and we tried several different thicknesses, and I don't know if it was the medium or the, I forget which one it was, but I was worried about the really thin ones, kind of having that metal memory. If you bend them too much, that it would be like that. You can always turn it over and clip it down, so if it's like concave, you can force it flat. But anyway, I'll put the details when we get the product in there to tell you how thick it is. And I think that's all the questions. So anyway, sorry about the battery interruption, but I'm excited. Next week, I hope to show this thing running and show the printer belt running and take more questions. Hopefully we'll sell some more Adopt-A-Bots and keep that program running, and then we'll be able to add this little project to it as well. But anyway, have a great week. Happy New Year. Thanks for tuning in, and we will see you next week with more news and projects. All right, take care.